Welcome. In a previous lesson, we worked with exponential functions that were exponential growth. Well, today we're going to be working with exponential decay. One of the big things is y equals a times b to the x is the form. A has to be greater than 0 and b has to be a proper positive fraction. So between 0 and 1. In all of those functions, the graph will fall from left to right. The graph passes through the point 0a and 1ab. The domain is all real numbers and the range is y greater than 0. So in that kind of situation, here's an example that we will graph. Now if I put in a value of x of 0, we typically start with that, then anything to the 0 power is the number 1. If I put in 1, then I get 1/10. If I put 2, I get 1 over 100, because remember, where that would be squaring both the top and the bottom. What if I put -1? Well, that's basically the reciprocal, 10. -2 would be 100, which is going to be off the graph that we can draw quickly, especially if we're going to include 1/10 and 1/100th. So then I have to plot my points. I've got -1, 10. -2, 100 is way up there. 0, 1. 1, 1/10. And 2, 1/100th. And you can hardly see the difference between those two, but it would be much closer to the line and it would be difficult to draw. So it's going to start almost touching the line, it's hard to draw that, and then it swoops right up, and that is your graph. Remember, you're going to have asymptote. It's a little higher than it should be. Come on. There it is. And there's your asymptote for this problem, right at the x-axis. All right, let's continue. Here we have y equals 3 times 1/4 to the x power. Now, the bigger the denominator, if the top is 1, the slower it goes up, the faster it's going to go up, and the smaller, the slower it goes up. The closer to 1 this is, the slower it will go up. Now if I put in 0, that's going to make this 1 times 3 is 3. If I put in, let's see, 1, that would be 3 times 1/4 or 3/4. 2, well, I'm going to square this, so 1 over 16 times 3 is 3 over 16. Now, I told you before I wanted at least two things with two coordinates with fractions in them, and these would be those two, just like we did on the other problem. If I go the other direction, -1, well, the reciprocal, -1 makes the reciprocal of this, so 4 times 3 is 12. And anything beyond that is going to be way off my graph. I've extended this graph just slightly so that it makes it a little easier for it to plot those points. Let's go ahead and graph this 0, 3, 1, 3/4, 2, 3/16, which is just a little under a quarter. -1, 10, 11, 12, I believe is there. Wait, let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, I do have that in the right spot. And then it's going to get close to 0, so that's not a very good start. Start again. And off it goes. All right. So there is your problem, and let's pick a different color here. There is our asymptote. That's how you do it. So now I'm going to use a problem out of the book. And this particular problem is a group of word problems. And this is 8.2. All right. In this problem, it says, a small business owner buys equipment for $40,000. The value in thousands of dollars of the equipment can be modeled by the function. Now notice they said the value in thousands of dollars of equipment is modeled, and V is the value, equals 40 instead of 40,000. 40 times 0.85 to the x. Yes, okay. Where x is the number of years since the equipment was purchased. Now they refer to this as depreciation of an item. As it gets older, it depreciates or loses value. And 85% is how much is retained, so that means it loses 15% every year. It wants us to make a table of values, then graph it. I'm not going to worry about the graphing part. Use the graph to estimate when the equipment will have a value of $11,000. Will the equipment ever be $0? Well, we know that it'll never actually get to 0 because this is between 0 and 1. So it'll continue to get small, but it'll never be 0. Now, if we really think about it, if it always followed just a formula, yeah, that'd be great. But it doesn't always just follow a formula. Now, it'll follow a formula for a time, and that's okay, but it's not always, because eventually nobody will want it, so nobody will purchase it. Maybe it'll be worth scrap. All right, so V for value instead of Y, all right? So the first, at 0 years, it's worth the full $40,000. Now, I'm going to write the full dollar amount instead of a decimal, because we know this is V is in thousands of dollars, so this is really V times 1,000 to represent the actual value. All right, let's take a look, and they want to know when is it that it's worth, what was it, 11,000? When will they have a value of 11,000? All right, so after 1 year, now I'm going to take and put 1 in here, excuse me. Thank you for all those bless yous. All right, 40 times 0.85 is 34,000. After 2 years, it'll be 28,900. After 3 years, it'll be 24,565 after 4 years. So I'm just using that new exponent, or if you're using it in your calculator, you're just multiplying the result of the previous times 0.85 again. 20,800 $80.25. 5 years. 10,000. Wait, that's not right. Let me do this again. That's better. I knew I had made a mistake. Must have hit some button wrong. $17,748.20, round it to the nearest penny, 1 cent, times 25. 6 years, $15,085.98. After 7 years, $12,823.08. 8 years. Boy, I hope I've got the answer now, because I'm running out of room. $10,899.62. So in year 12, 8, 10, 10, 8. No, I said it right eventually. In year 8 is when it's worth approximately $11,000. So that is the process to get that answer. This was the formula. I made a table. We found. Now, we didn't find it by the graph because unless you're using a computer-aided grid graph, drawn graph, it would be very difficult for you to use a graph to approximate a value like this. I can't imagine trying to draw this perfectly so that it comes out and shows this value. Now, if I use Desmos or some other graphing calculator, you could trace it along right from this and not need to make the table of values. But it turns out we could make a table of values and find approximately where it would be. So, there you have it. I don't think I have any more for you today. So, I hope this all was clear for you today.